Yo, 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 everybody. So we're going to start 4.1, and we're going to talk about linear, non-proportional relationships. So first, if we look at the word linear, that means an equation that makes us a line when we graph it. So linear equation is an equation that makes a line when we graph it. And a linear equation is always in this format. It's always going to be y equals some number times x. We call that some number the slope. And then plus another number, plus some value or minus a value. And we'll get into what this number is later. This is the value that makes it no longer proportional. Okay, so if we have a linear equation that has, so this would be an example. I could have like 2x plus 1. Because it's plus 1, it's not a proportional relationship, because we know proportional relationship has to have just the 2 times x. Okay, because we can't have plus or minus anything else. So this is proportional. This makes it non-proportional, but it's still a straight line. And this number is the slope. Okay, so it's the slope of the line. So we're going to talk about equations that look like this, and we're going to take it super simple today. So what we're going to do is we're going to be given an equation, and then we're going to create a table, and then we're going to take that table to fill out the values, and then we're going to take those values and put them on a graph. So here's the equation, y equals 3x plus 2. Okay, so y equals 3x plus 2. So it's non-linear. It's linear, but it's not proportional because I have this plus 2 here. So what this is this person is renting a pair of bowling shoes, and they're going to bowl X amount of games. So it's $2 to rent those bowling shoes, and then it's $3 for every game that they bowl. So we're going to make a table of values for this situation. So we're going to talk about if they bowl 1 game, 2 games, 3 games, or 4 games. So X is always on the top, Y is always on the bottom. My X here is the number of games they play, and then my y is the total cost. So what we're going to do is we're going to take these x values and just plug them into the equation. So I'm going to take them and plug them into this 3x plus 2. So for x is 1, I can plug that in for 1 into the equation, and then I can actually solve that. 3 times 1 is 3. 3 plus 2 is 5. So if they bowl 1 game, they're going to spend a total of $5. That was $2 for the shoes. And then 1 game at $3 a game is $3. So they're going to spend a total of $5 to bowl 1 game. If they bowl 2 games, again, so now I'm just plugging in 2 for x. Well, if they bowl 2 games, that's $6 for the 2 games plus the $2 shoes. So that's $8. If they bowl 3 games, I can solve it by plugging in a 3. 3 times 3 is 9, so that's $3 per game. They bowl 3 games, that's $9 for the games, plus the $2 shoe rental, which is $11. And then finally, if they played 4 games, we're going to also have to plug that into this original equation. 3 times 4 plus 2, so that's going to give me 12 plus 2, which is $14. Okay, so I filled out a table. I figured out how many games they play. So when my x is 1, what's my y value? So I can plug in 1 for x, and then I can figure out the y each time. So that's how I got y equals 5. This one's how I got, because it's always y equals. This is how I got y equals 8. This is how I got y equals 11. Y equals 14. And those are my values of the table. That shows me the slope is, if I look at my slope, my change in y is 3, my change in x is 1, and it continues, so that's my slope is 3. And then those are all the values. Okay. Now, if I wanted to graph this, I could plot, these are all ordered pairs that I could plot on a coordinate plane. But we're going to move on to the second one here. So the diameter of a Douglas fir tree is currently 10 inches when measured at chest height. Over the next 50 years, the diameter is expected to increase by an average growth rate of 2/5 inch per year. So there's a growth rate of 2/5 inch per year, and it's starting at 10 inches already. So we're going to take our starting point from 10, and then we're going to add that 2/5 per year. So we want to draw a graph of the equation. So if I wanted to graph this table, what I'm going to do is I'm going to figure out my x and y values, and I'm just going to use easy numbers. So I'll use 0, 1, 2, 3, 4. Or what I could even do is I could, if I wanted to make this a little bit easier on myself, because I see that this is 2/5, if I wanted to go by multiples of 5 years, I could do that, because that's going to make the multiplication really easy. So I get to choose my values. I'm going to go by multiples of 5. If you wanted to do 1, 2, 3, 4, it doesn't really matter. I'll show you why I did multiples of 5. So those are my x values. So now, for my y values, what I'm going to do is I'm going to plug it into this original equation that they already gave me. So my equation is y equals 2/5 x plus 10. So my slope is 2/5. What I want to do is I'm going to plug in these values for x, and then I'm going to solve. So if I have x is 0 plus 10, I want to figure out what my y is. What I did is I took x is 0 and I plugged it in for x here. Okay, 2/5 times 0 is 0. 0 plus 10 is 10. So y equals 10. That's an ordered pair on my graph. So this is the ordered pair of x is 0, y is 10. So x is 0, y is 10. Let's take this graph and let's count by 5s on the graph, and that'll make our lives a little bit easier. So if this is 5, this will be 15, 25, 35, and we'll do the same thing with our x values as well. So that'll be 5. Whoa. This one will be 15, and so on and so on. Okay. So I have the point 0, 10. When x is 0, so my x values are always going left and right, y values are always going up and down. When my x is 0, my y is 10. So I'm going to plot that point. We'll do it in purple. So that's right here. That's 0 and 10. Now let's figure out when x is 5. So if I do 2/5 times 5, I took my x value, plugged in 5 for it, and then I add 10. Yes, I have to multiply fractions, but here's why I chose multiples of 5. Because the denominator is 5. When we multiply these just multiply across. So I can do 2 times 5 is 10. 5 times 1 is 5. But this gives me 10 over 5. 10 divided by 5 is 2. And I just keep bringing down that plus 10. So here I get 12. Okay. So because this one is 12, it's going to be right about there. Not perfect, right? But there we have it. Okay. So again, what I want you guys to do from here is I want you guys to plug in 10 for x, plug in 15 for x, plug in 20 for x, and solve these 3 equations and plot your last points on this graph. Okay, so hopefully you did that. Hopefully you plugged in your values here. So now what I want you to do is I'm actually going to unpause. I'm going to pause it real quick. I'm going to show all the work so that when you unpause, you're going to see all the answers. So hopefully you already have values for 10, 15, and 20. You should. And then you can check your work. Okay, here's what you should have had. You should have had 14, 16, 18. It continues the pattern of increasing by 2. If we notice my slope, I'm going up 2 each time, up 5. So my slope is 2/5, which is what is the value right here. Here's my graph. If I were to connect all these points, I'm not going to right now, just because I don't want to blur in because it's a small handwriting. But if I were to connect all these points, it would be a straight line. Now, these points aren't perfect points. They were estimations because we decided to count by 5s. But that's okay. It still makes a straight line, which is because it's linear. If I knew it was linear, if it looked like this and I graphed it and it didn't make a straight line, we would have issues. Here's all the work for how I got those points. Okay, so now I have an equation, y equals 12x minus 4. Okay, 12x minus 4. So the number of hours they work is going to determine how much money they make. So they make $12 an hour, but they have to spend on $4 of transportation. So every time they have to spend $4 to make $12 an hour. So that's why they start off at -4. So we want to figure out, let's go for 1, 2, 3, and 4 hours. Go ahead and see if you can fill this table out on your own. So complete the rest of it, try it out, see how you do. Okay, there's all your answers. So I chose 1, 2, 3, and 4 hours, which you guys should have already had. So that means they made 8. If they work 1 hour, they make a total of $8 because they have to make that $12 per hour, but they have to subtract that $4 for transportation. So they're only walking away with $8 positive. 2 hours would be 20, 3 would be 32, 4 would be 44. Here's all my work to show how I got those answers. Okay, and then I believe, yep, this is the last one, so go ahead and pause it. And again, now we have a negative. The negative doesn't change the process. So I have -2 times x plus 1. So that means I'm going to do here, I'm already given my x values. So I'll do the first one for you. If I have -2 times x, well, if my x is -1 plus 1, I have to follow my rules of negatives. A negative times a negative is positive. So that's going to give me y equals 3. Finish the table and then try to plot those points on your coordinate plane. So finish the table, pause it, plot them, and then see how you did. Okay, so here's my graph. Here are my points. So I got 3, 1, -1, -3. Notice how every time I go up 1, I'm going down 2 because the slope is -2. So I'm going down 2 each time as I'm going up 1. So that follows my slope of -2. Here's all the work for how I got 1, -1, -3. Remember, negative times a positive is negative. These are the ordered pairs of these points, so they do make a straight line, and it shows a negative slope going downhill. Okay, so really this is just plugging values in and into an equation, plugging your x values in to figure out your y, and then putting them on a graph. And that's all I got for you guys today. You have an independent practice, make sure you get it done, and make sure you show the work. If you do not show the work, you will not get credit. Thanks for watching. Good to see us out.